As much as we like to spend money on the latest, greatest planes and missiles, the biggest vulnerability of the U.S. military is fuel supply. Our models show an airborne wind energy system could reduce that fuel requirement by up to 80%.
This is EnergyCast, and I'm Jay Dowenhauer. Today we are talking about airborne wind energy, the free-flying technology that's taken off. And it's a technology taking a lot of forms. There are currently no commercially available products, which is exciting in a way because what we know as airborne wind can vary wildly. The loose definition is essentially power without a tower. Sometimes the turbine can be held aloft with a blimp, sometimes a wing like a kite. In fact, some airborne designs don't even produce power in the air. The guest we're speaking to today originally adopted a reel-in, reel-out design, whereby the energy was created from a generator on the ground and energized by the constant pulling motion from the airborne vehicle. The biggest player in this sector right now is Google X, the moonshot division of the parent company, now calling itself Alphabet. They have developed a glider design with turbines in place of propellers. The unit stays aloft and generates power. This is very similar to the path our guest today is pursuing. The benefits of this technology are, first of all, a lighter footprint. Similar to the Barber wind design we profiled a few weeks ago, there is no need for cranes or bulky equipment to set up these units. In this case, all airborne wind units are connected to the ground by a tether. It's this mobility that makes this technology especially attractive to places where there is little transmission infrastructure, like the developing world and mobile bases. In fact, through the Military Small Business Innovation Research, or SBIR program, our guest has been able to secure important seed funding that is critical to the research and development of this technology. It's also important when you're not a Goliath like Google with $94 billion in cash reserves. An investment in airborne wind also makes a lot of financial sense to the Defense Department. According to a 2009 article from The Hill, the Pentagon pays about $400 to get a gallon of fuel into Afghanistan, and nearly half of that is used to run generators, not trucks or tanks. With economics like these, a relatively small investment in technology like airborne wind to offset huge fuel tabs could yield extraordinary savings to taxpayers like you and me. Our guest today is Rob Creighton, CEO and founder of Windlift, an airborne and wind power company. Windlift was founded in 2006 and has been moving towards a commercial model since then. I mentioned earlier that they started out with a reel-in, reel-out design. They have now moved on to a model that takes off, lands, and flies all at the push of a button and all controlled by a computer. I sat down with Rob 2 weeks ago at his office and workshop in Raleigh. The amount of progress he's been able to make on such a lean budget should make the folks at Google shake their heads. I hope you enjoyed my interview with Rob Creighton. We're here with Rob Creighton, CEO and founder of Windlift. Rob, tell us about the inspiration for this design. It's kind of like a glider. It's kind of like a drone. What really was the inspiration for this design that you've come up with?
The inspiration, I was actually sitting in church in Madison, Wisconsin in 2003 or 2004, and they had kind of a hanging the cross and all the stuff, and I just was kind of looking at it. I was thinking about energy and wind power and just started to have this image of what it would look like. And I'm not really a blatantly religious person, but it was almost a little bit of a religious moment where I thought, why can't we generate power that way? And started building prototypes. They worked enough to keep me excited about it. What was more interesting and more exciting was the way they failed, because there was too much power in the system and they kept breaking. Typically in renewable energy, you're trying to extract every last bit of efficiency out of a system. With airborne wind energy, it's typically have the opposite problem, in that there's so much energy in that system and you're dealing with very lightweight components to handle those loads. Really exciting exciting.
This family of wind is called airborne wind energy. That's the subset, right? Tell us a little bit, what's the defining characteristics of this family of wind energy?
You're using the lift on the wing. So anytime you want to extract power from the wind, you always want to generate lift from the wind. So that's the name of the company, Windlift. But for airborne wind energy, instead of using a big tower attached to a foundation with a turbine at the top of the tower, you're actually taking some of the energy from the wind and some of that lift to resist gravity to stay aloft. That's the definition, is you're airborne. You're lifted by the wind.
Explain how it gets airborne and then powers operations on the ground. And this was an evolution, wasn't it? From
right.
To where you are now, right?
So you can launch it just like a kite. As the technology's evolved, now we use small turbines on the wing, and we put a small amount of power in the system to get it in the air. And once it's in the air and it's moving, literally 4 or 5 seconds after you launch, you can actually start generating power from the wind.
You described it looking like a helicopter. It kind of reminds me of those Osprey aircraft, right, that take off vertically and then they're flying like a regular airplane, right?
Yeah, it's more what we use now is the quad rotor technology. It's like a quad rotor drone. All that technology has become open source. We use that as the core for launching and landing. And then most of our evolution has been building simulation models that teach a computer to fly the system and generate the most amount of power from the system.
So are there flaps on it, or is it just the propellers?
So you have 4 motor generators hooked to propellers, and then you have 4 flaps, and then 2 ailerons. In the back, you have something called an elevator, and then you have, on the same tail, you have a rudder. So basically 3 different axes of control that you can manage.
In all the videos that I've seen of this, it's flying in a figure 8 pattern, is that right?
That's right, yeah.
Is that always the configuration that you plan on flying it, or was there any kind of point where the design was just going to be, it's just going to fly straight up like a kite and suspend up there? Or?
So to maximize the power from airborne wind energy, you always want to be flying across the wind. The simplest way to think of it is if you're to like kind of hold up a big circle in the air, there's a certain amount of wind that would pass through that circle, and that air mass has kinetic energy. Simplest way is put a turbine into that airstream. But with airborne wind energy, because we're sweeping across the wind, we can actually have a simple wing that's not confined by the swept area of a turbine blade. So that's why wind turbines always want to get bigger and bigger and bigger and bigger. If you get a little bit longer, you're getting much more power because it's an exponential function. The bigger you go with wind energy, the more efficient it is. Airborne wind energy blows that whole paradigm out of the water.
You described a design you had earlier where rather than the power being generated from the propellers that are on the glider, there was a motion where the glider is pulling a tether attached to a generator at the bottom. Explain very simply how that works, and you said you abandoned that idea and why you decided to just leave that idea on the ground.
Yeah, it's called a reel on, reel out generator. So you have no turbines on the wing, and the tether is passive. So you can actually control everything from the ground, and you don't have to have anything in the air. When we used to work with that model, we'd lose control and it hit me in the head a couple times. I'm still okay, I think. It's a great way to prototype and test, but there were a lot of challenges with it, especially the launching and landing part. And also with that model, when the wind dies, you have to land. Just the concept of operations was challenging. We couldn't really make it work.
Great inventions are born out of need, I like to say. What was the need you were trying to satisfy here?
Because airborne wind energy is not confined to this wind energy paradigm where bigger is always better, it allows you to make a smaller system that's still relatively efficient. And that means that you can open up lots of new, smaller distributed markets for wind energy that couldn't be tapped by existing wind turbines. Airborne wind energy allows you to get a lot more power out of a very relatively small, lightweight vehicle. So for instance, Windlift has been funded by the military primarily because they want to have power in remote places. They have looked at solar, and solar has challenges because the panels are big. Solar is great for grid-tied systems, but it has challenges when you're in a remote place and you need to hook it up to batteries. So we've kind of created this model of a system that's a fully mobile power station that's got an airborne wind energy as like its core, and then has accessorized with solar. You can accessorize with a diesel generator, and then it has a battery pack. And because airborne wind energy is so light, our 15 kilowatt wing only weighs 120 pounds. That's a lot of power that you can get out of a really small package. And that's exactly what the military wants. That's what people want for disaster relief. That's what people would like to have for offshore wind. Those things all kind of go together, and that's our goal eventually.
Definitely smaller than a wind tower, that's for sure. 15 kilowatts, how much would that power on the ground?
Well, your house probably uses between 1 and 2 kilowatts, so between 5 and 10 houses. That could be a base camp for a small group of guys, 8, 10 guys that need to purify water, make ice, to HVAC, power computers, communications equipment. All that could power with one of our systems.
Rob, we hear so much about wind being intermittent, but you claim you can deploy power 24/7. How is that possible?
Because our system is so light and we generate a lot of power when there's wind, we can put that power in a battery and then use it throughout the day. And then our system we're designing also has a backup diesel generator and solar. You can go periods of time without being able to get access to diesel fuel. There's all sorts of risks to your energy supply. If you have a diversified supply, you're going to be much more likely to have power 24/7.
How much wind is no wind? How much wind does it take to be airborne?
Our models put it between 12 and 14 miles an hour before you start generating usable power, and then we really quickly ramp up to our full output at 22 miles an hour.
You throw a kite up in the air, it really seems to get its bearing when it's a couple dozen feet in the air. Is there a sweet spot that you aim for as far as how high the glider needs to be?
Yeah, that's a lot more complicated question than you'd think. It really depends on, we call it the surface roughness. If you're in a city, you might want to be 200 feet in the air, 300 feet in the air. You want to be about 100 feet above any obstructions.
With the computer system that guides the unit, would it be able to find that sweet spot? Or
Yeah, the computer, we're designing it to, you'll have 3 buttons to push as the operator. Launch, land, maintain altitude. But you want to design the system from our perspective so that you're always kind of 100 feet above that boundary condition. And it's actually way more than a human operator can manage. If I'm trying to pilot it, I cannot manually pilot it nearly as well as a computer can.
What are some of the upper limits? We're in hurricane season right now, probably not a Cat 5, but rain, snow, things like that, can it still operate?
Yeah, rain doesn't worry us. In theory, we could probably fly through, 140 mile an hour hurricane as long as the anchor point wasn't blown away. In theory, it could fly and generate power that whole time too. So we could be generating power in 140 mile an hour winds.
That's amazing.
It wouldn't be flying figure eights anymore. It would just be hanging there, gliding, trying to minimize the tension in the tether. Snow and icing conditions may create challenges. There are some new technologies. We use carbon fiber in our wings. There's new coating technologies that you can use. They're conductive that allow you to de-ice automatically if you have enough power, and that's something that we have plenty of.
I thought it was interesting that these units could serve some other useful purposes while in the air. I think I saw something about Wi-Fi, for instance. Tell me about the other benefits of having something that's up high in the air, the other benefits it can generate other than just electricity.
Yeah, antennas, if you want to have line of sight communications, which are the most efficient way to do communications, the higher you go, the wider your area is that you can cover with a signal. The other interesting thing is if you wanted to do radio repeaters, if you were to daisy chain our systems to create a mobile network that can have very, very high bandwidth.
The presentation you sent me was geared toward military operations. Tell us how you think Windlift would fit the needs specifically for the military.
Yeah, so they are the most mobile power users around. They have to go into challenging environments, they have to set up camps, and they have to have power. For instance, in Afghanistan, I think they were shipping 600,000 gallons of diesel fuel a day from Pakistan primarily, and they would ship that fuel through the mountains between Pakistan and Afghanistan. And who controls those mountains was the Taliban. So,
let's not forget that the diesel fuel was not $2.15 a gallon either.
Yeah, it was more expensive. It was $5 a gallon, and we were spending tens of billions of dollars, I think, when they added it all up, both buying the fuel, shipping it, and more importantly, because we were so dependent on that fuel lifeline, I've heard they only had 3 million gallons of storage capacity in Afghanistan, and they were using that much fuel a day. If that fuel supply was cut off, they were going to run out of fuel in like 6 days.
Yeah, that's a tight supply chain. Yeah.
That's a tight supply chain, so that's just in time, and when you're in a security environment, that whole effort over there could have been shut down. And as much as we like to spend money on the latest, greatest planes and missiles, the biggest vulnerability of the US military is fuel supply. And over half of that fuel goes in generators to generate electricity. Our models show, theoretical at this point, but show that an airborne wind energy system could reduce that fuel requirement by up to 80%. So right there, you're cutting 40% of the fuel requirement, which is a big deal. And more importantly, if you aren't driving trucks around, you aren't flying airplanes every day and helicopters, you can sit there indefinitely and you can save your fuel for when you really need it. It changes the whole mindset, whereas you're not constantly rushing to get something done. You can actually stop and say, okay, let's work with the local population. Let's give this local villager an airborne wind energy system, and now he's got Wi-Fi. It's a potential way to change the whole climate over there for the positive. It's climate change. You'd like to change the climate in Afghanistan, the political climate, and also really give people power to do economic development.
Tell us a little bit more about what it's been like working with the military. Are those SBIR?
Yeah, we call them contract awards.
Okay.
They call it an award because we've done good service. The contract is basically structured, so we're doing contract research and development. So instead of them paying scientists in the Army Research Laboratory to do this work, they hire us. The only difference, of course, is because we're doing this work for them, we actually get to keep all the intellectual property that results from that work. But we have to sell them the product that comes out of that intellectual property at a cost plus fixed fee.
What's the feedback you've gotten from those guys?
They're just now starting to kind of appreciate the strategic potential of this technology. As we've started to understand what their challenges are, and as they're learning from Afghanistan, their mindset has changed. I see this economic development piece of the mission as being the mission.
Let's talk a little bit about the company. Would you say your glider is commercial at this point, or
No.
what was it going to take to get to commercial?
The military market, they've funded us to develop the computer models and do mock-ups and demonstrators. We're still trying to convince them to fund a fully functional prototype. It's a chicken and egg problem. So you have to have prototypes to demonstrate, to get more funding, to build more prototypes. For us, our system has so many underlying core technologies that all have to work together in harmony that it's a challenging engineering problem.
You described you had some equipment up at Quantico. What can that do right now?
It can give people an idea of what it looks like.
Yeah.
It's all the pieces are there. There are a few electronics components that we're still optimizing for that. So.
Okay, but you do have the models. You have a pretty sophisticated computer model up and running.
Most
right?
of what we've done in the last 3 years has been simulation and modeling. We have to teach a computer to fly the system before we can build the system for it to fly.
We had an interesting talk a little bit earlier about approaching venture funding, and tell us a little bit about that experience and I guess where you've seen success and where you've seen a little bit of frustration and all that.
Yeah, I've been on and off trying to raise money from professional venture investors for 11 years. And over that time, our technology's evolved a lot and our ideas of what we can do with it and how it's all going to work has changed. The venture model, I think it evolved in Silicon Valley, or it's very software based, or it was incremental improvements to existing hardware. It's very difficult to do hardware and software engineering. It takes a lot of funding to really make a competitive product that you could sell commercially.
It seems like a lot of venture fund guys want to do a lot of software as opposed to a lot of physical things, hardware, like what this is.
Yeah.
One of the benefits, I guess, of software is that they can build what they call a minimum viable product, whereas what you're doing, you have to physically go out there and build it. So
that's right.
There's a little bit more capital involved. You have to wait a little bit longer for something that's fully functioning.
I think their investment model is just not very well structured for hardware investments. There's the idea that they don't want to take a risk on top of risk.
Yeah.
So, they always sometimes exaggerate the risk, but they might say you have a 1% chance of succeeding and making the hardware, and then you've got maybe a 1% chance of making the software integrate properly with that hardware, and then you've got a 1% chance of finding a market that this all serves properly. So they would say your odds of success are points,
1,000th of a percent, it seems. Yeah.
If you're just doing the accounting, it is risky and it's challenging. I've been at this a long time and we've learned a lot. We've had a lot of time to sit and think because we haven't had the resources to do the hardware. Because every time we do a prototype, it costs money. There's no shortcuts around it. You can't sit in a garage with a couple of guys and a computer and a 6-pack of beer and make a prototype. That's how you can do software development. You can really get a minimum viable product in a dorm room where all these questions that come up when you're actually making stuff. But on the other side, it is so hard that when you do achieve success, your barrier to entry is huge. And that's the piece of it that sometimes gets lost when you start doing the accounting, is that if you have a dedicated team of people that believe in what they're doing and are willing to move mountains, like we do here at Windlift, we've got an opportunity to do something great here. And if we can find the right partners, I think airborne wind energy is uniquely positioned to tap into this incredible marketplace that is growing around the world.
Let's talk a little bit about the competition, this umbrella of airborne wind energy. Who are the players out here right now?
Yeah.
What does that market look like right now?
Well, to call it market is maybe generous.
Sector.
Nobody currently has commercially available airborne wind energy systems. I would say talking about the sector as a whole is, for one, in the US at least, the FAA has still not decided how it wants to treat these systems. You can get one-off permits, but there's really no idea of how these are going to be spread around the country. In Europe, most of the European organizations follow the ground gen model in different variations, and they're made a lot of progress. So there's just recently been some big investment in Europe in airborne wind energy. But the big player is here in the US, and that's Google X. Google X has put maybe $150 million into airborne wind energy. And they are trying to scale up and replicate the model of the wind turbines. So they have a 600 kilowatt system. I think it's a 90-foot wingspan system. And they've been testing that system in the Big Island of Hawaii for the last couple of years to some success. However, they are notoriously secretive. So Google X has become kind of a top secret skunkworks, if you will. It's a complicated history, but I started Windlift in 2006. In that same year, there's some guys in California. One of them was Sergey Brin's kiteboarding instructor. Kiteboarding is a sport that's he just started in about 2001, and as that technology has improved, same concept basically. Tether, wing, huge amount of power. So it's definitely a sport for adrenaline junkies.
I'm going to finish with a lightning round of your thoughts on different energy technologies. And I do this for everyone, and this is like free word association. So here we go. Natural gas.
Climate change accelerator.
Crude oil.
Polluting and running out.
Nuclear.
Mutant babies.
Coal.
Mercury poisoning of fish.
Wind. Let's do this. Conventional wind.
Amazing technology, innovation, limited onshore locations.
Airborne wind. You guys.
Someday, soon, will be the lowest cost source of electricity.
Solar.
Chinese industrial engineering.
Biofuels.
Food to fuel.
Fuel cells.
I don't know much about fuel cells.
Okay. Hydroelectric.
Limited overall potential. All the best locations have been used.
Geothermal.
Location specific.
Electric vehicles.
The answer to transportation.
And finally, nuclear fusion.
They'll make it work in 10 years.
10 years. Well, that's very good. All right. Rob Creighton, thank you so much for your time.
Thank you. It's been fun.
All right. That was Rob Creighton, CEO and founder of Windlift. Rob says his next step is to secure funding for a working prototype. During our visit, he showed me a computer simulation of his glider in action, flying in endless figure eights. It looked a lot like those flight simulator games we used to play on our PCs. Special thanks to Rob for his time and Kirsten Williams from Walk West in Raleigh for setting this up. She mentioned this during a lunch we recently had, and I jumped at the opportunity. All guests are sent the raw and completed program the week of release. So far, no complaints. Music was produced by Sean Stroop at Stroop Loops. You can check out links and pics of Windlift technology in action on Instagram at Host Energy and online at energy-cast.com. That wraps up episode 22. Please sure to join us next week when we take a look at what could be the most energy-efficient carbon capture technology being developed. You won't want to miss it. Until then, I'm Jay Dowenhauer. We'll see you next time.